Okay, so let's continue on stoichiometry. Okay, so just to mention, or just for the factual purpose, these compounds in which you can find hydrogen molecules embedded, you can call them as hydrated compounds. Okay, next we will be talking about these terms, which is called STP, which is standard temperature pressure. Okay, and we'll also be talking about the old term used for the STP, which is NTP, which is normal temperature pressure. Okay, nowadays we use the new term, which is STP. Okay, now let's discuss on the molar volume of a gas. Okay, so molar volume of a gas is represented as Vm, and this is defined as the volume of 1 mole of a gas is a molar gas. Okay, so I hope you remember that the equation of an ideal gas, or the equation which ideal gas follows, this is V upon N. V upon N is equals to RT. So in other words, you can write it like V into Vm is equals to P into Vm is RT. Vm is nothing but molar volume. Okay, so at STP, what will happen here, what will happen to the equation is, normal temperature and pressure means pressure would be 1 bar. Okay, and temperature would be 273 Kelvin. Okay, so what happens to volume? Volume is obviously, or rather Vm would be RT, because P is 1. Okay, so this implies Vm equals to R is 0.0, or rather 0.82. Okay, and temperature is 273. Hence molar volume of ideal gas at STP is 22.4 liter. Okay, and how will you calculate the number of moles if you are being given the volume? So we know that Vm equals to volume divided by number of moles. Okay, hence this implies number of moles would be volume of gas at STP divided by 22.4. This would give you the number of moles. Okay, if you have been given the volume of vessel, or in other words, volume of a gas. Okay, or you can also say that 1 mole equals 22.4 liter of gas at STP. Okay, so next we will see some questions on it. So you have to calculate the Vm of gas at, you have to calculate Vm at 76 mm Hg and 273 Kelvin. Okay, so I hope you remember that 1 atm equals to 760 mm Hg. Okay, so 76 mm Hg would be equals to 0.1 atm. This is the pressure, or P. Okay, so this is ideal gas. Okay, I forgot to mention, but this is ideal gas. We are talking about ideal gas. So P Vm equals to R. I hope this is 0.082. I forgot to write it in the previous example as well. This is 0.082. Okay, 0.082 into 273 so Vm equals 0.082 into 273 divided by 0.1, which will give us how much? So this is 22.4 and this is 0.1, so it will be 224 liter. Okay, so molar volume would be 224 liter per mole. Okay, next question is, you have to calculate the pressure in 2 moles of gas present at 10 liter present in a 10 liter vessel at a temperature of 400 Kelvin. You have to calculate the pressure. Obviously the gas is ideal. Okay, so PV equals to nRT is the equation, followed by ideal gas. Volume is 10 liter, number of moles is 2, R is 0.082. okay, and obviously T is 400. So from here pressure can be calculated and it should come out to be 6.56 atm. Okay, now let's do another question. You have to calculate the Vm of a gas, okay, at 1 atm and at 300 Kelvin. So obviously PVM equals to RT for ideal gas. Until unless it's not specifically mentioned that it's a real gas, we'll be treating the gas as ideal gas. Okay, so 1 into Vm equals 0.082 into 300. So from here Vm will come out to be, I hope you can calculate it. Okay, whatever the answer. Okay, so next we have, you have to calculate the number of moles present in 5.6 liter vessel at pressure of 1 atm and temperature of 273 Kelvin. Okay, so again PV equals to nRT, pressure is 1, volume is 5.6, number of moles you have to calculate 0.082 and temperature is 273. Okay, so from here and will come out to be 0.25. okay, let's have another question. You have to calculate again number of moles present in a gas, or rather you have to calculate number of moles and of oxygen atoms present in 448 liter of ozone at 1 atm and 273 Kelvin. Okay, so number of moles of O3, I'm just writing here, number of moles of O3 would be PV upon RT. okay, and we'll be getting here P is 1, volume is 448, R is 2, this is 273, so it will come out to be, so just to mention that these are the number of O3 molecules. Number of oxygen atoms would be 448 divided by 0.082 into 273 times 3, because one O3 molecule contains 3 atoms, so it will come out to be 3.6, or rather this is the number of moles of atoms. Okay, so for calculating total number of, this is the number of moles of oxygen atom, and if you have to calculate number of oxygen atoms, then you have to multiply this x with times Avogadro number, which is 600 times per 23. So you can calculate it and it should come out to be 3.6 into 10 to the power 25 atoms. Okay, so with this we come to an end of this lecture. We'll meet in the next lecture.